Hello, hello. Are we live? Yep, we're up and running. Welcome back to the advent of Syntran. Today is day 10. I always have to look at the calendar because I forget which day it is, but it's day 10. So let's make a new day. Finally a 2-digit day. I have to edit both digits now. Usually I just, reverse incremental search my previous commands. I only have to change one number, but today I have to change 2 numbers. Here we are. Let's find the test input. So which thing is actually the test input? I think I have to read this before I figure out which one is the test input, because there are too many code blocks, or pre-formatted monospace font for blocks. Hello, Nick. Welcome to the stream. So we have pipes. And these characters represent elbows. Well, that's confusing. What am I doing? I'm doing Advent of Code. These are programming puzzles. They're all Christmas themed. If you've never heard of these before, every December 1st through December 25th, they unlock one puzzle each day. Each puzzle has 2 parts, so when you solve the first part, you unlock the second part of that day. So today's December 10th, that means I'm on the 10th puzzle. Okay, F. All of these characters are elbows. That's really confusing because L looks like an elbow. 7 is not bad, but like F and J are really questionable as something that graphically looks like an elbow. But okay, I get it. That's fine. We'll play along with this. I guess it's better than resorting to like some weird extended ASCII character that looks more like a pipe. The animal? What is... I don't know what the animal is. Oh, so the animal is inside some of the pipes? Okay, I think this is not really the test input. This is just a more minimal example. Okay, so the S would mean that the animal starts at the S. Oh, so we're just supposed to infer that this is an elbow based on the adjacent pipes. But in here, okay, so this type of elbow, the 7 elbow connects to the, let me mirror my webcam. The 7 elbow connects to the left and it connects to the down, but it doesn't connect in any other directions. A vertical pipe connects up and down, a horizontal pipe connects left and right, and so on. Basically, every pipe has 2 connections, so now you have to figure out which ones aren't part of the main loop, or at least not the loop that the animal starts in. Yeah. Two neighbors. Yeah, every pipe has two neighbors. And S is special because we can't tell which pipes S connects to, but we can tell which pipes connect to S. So here, I'm not going to read the next paragraph. S is connected here, and I think J is this kind of connection. Or, no, J is really confusing because it looks the least like a pipe. Connecting north and west. So that for the camera. Okay, so J connects, yeah, so that should be connected to the animal. North and west. Okay, so everything except ground in this example is part of the main loop. And if you fill it in with extra junk, it looks like this, but it's the same main loop in both of these cases, but here the other pipes are just not really connected to the main loop. Yeah. So here J would be furthest from the animal. We're trying to stay away from the animal, so we want to maximize our distance away from S. So I think if anybody has done previous advent of codes, you might look at this and think it's a two-dimensional search problem, but it's not. The overall space might be two-dimensional in some sense, but the pipe is one-dimensional. You can go along the pipe in the positive direction, or you can go along the pipe in the negative direction, but you can't go sideways out of the pipe. You can turn in an elbow, but the pipe is really a one-dimensional thing. So I don't think you really need breadth first search or depth first search. Definitely not anything as complex as Dijkstra. I think we can take the starting position. Once we find the loops, or maybe we can do this while we're finding the loops, we're going to go away from the starting position in one direction and mark the distances. So then we'd have 2, 3, 4, as it is shown right here. And then we're going to keep going. So when we get here, we'll say 5, 6, 7, and then finally we're back at the beginning. Then we're going to go back around in the other direction, and we're going to have 0, 1, 2. Now, these are not like 7 and 8. These are 1 and 2, and then 3, 4. And then again, we're going to keep going, but we're going to compare the minimum distance from the other time that we traversed the pipe. So this would be 5, but we know we had a 3 here before. So the min of 3 and 5 is 4. So we're going to permanently mark this as 3. And then after we make a full cycle around the pipe in both directions, then we'll know that this 4 is the max. Okay. So basically this We have multiple test inputs here. You can work with this one. Maybe there are 4 different test inputs here, but like I think maybe I do want to work with the most simple one first. Yeah, I think I want to work with this one. This one is too easy because you don't have to figure out which pipes you have to ignore. In this one, you have to ignore some pipes because like it's not connected to all of its neighbors, or it's at least not connected to the starting point. So I think I want to test my program on this, and then if I can get that working, I'll test it on this, and then I'll test the real data. Let's just save the other test input while we're at it. Okay, and we should be able to echo the test input. So there's the more simple of the 2 test inputs. This just has a square loop sort of centered in the grid. Okay, so I'm going to count the number of characters in the first line, I'm going to count the total number of lines, and then I'm going to pre-allocate a matrix or a rank 2 array to contain this data. I'm trying to think if I want to like encode these as integers or just deal with characters. Last year I was pretty fancy and I would always encode things as integers. But I don't know. Is that too abstract? Is that more abstract than it needs to be? Yeah, why not deal with characters? Let's try it. So I'm not, yeah, how do I want to do this? Because I could have a vector of strings, or I could have a matrix of characters. And those are kind of the same, but the syntax is a little bit different. I think a matrix of characters is better. And syntran doesn't actually have a character type yet, but after like 10 days of advent of code, I think I need to add a character type. Because what I'm doing right now is I'm using strings of length 1 when I'm dealing with characters. But there are a lot of algorithms where you can apply something to a character, but it doesn't make sense to apply it to a string. So there are very good use cases to have a separate character type besides strings of length 1. Let's get out of here. Okay, so we're not even going to read the file like this. We're going to count the lines first. And this is going to be the number of y values in the 2-dimensional grid. So you have x vertically and x horizontally and y vertically. And y is going to be positive down because that's the order that we're going to read the file in. And then I will want to allocate a matrix or a rank 2 array, whatever you want to call it, a table. And it's going to be a table of strings. I'm going to call it the grid, or maybe just G. Maybe grid, why not? It's going to be strings. Doesn't matter what the length of the string is. An array of strings is just an array of strings. They could be length 0 or 1 or whatever length a string can be. And there's no upper limit, but the table is going to be nx by ny. So this is going to be a while loop, like the letter Y, not a while loop, but a Y loop. And then inside that, there's going to be an X loop. And the grid is just going to be string. We only have the string for one line at a time, IX. And then I should be able to echo that grid. So there it is. We have a bunch of comma separators now because it's a matrix of characters. So we have this horizontal pipe, then an L pipe. There's the S. All of these characters look right. In the lower right, we have an F. I think that is loaded into memory correctly. So we're going to start at the S, and we're going to try to go around. So we're going to look at the 4 neighbors of S. We only have to worry about 4 neighbors of each point. We don't have to worry about the diagonals. Like, there's no way this diagonal could be connected to S. But any one of these 4 neighbors could potentially be connected to S. So this is connected to S because that pipe points in the right direction. And this is also connected to S because that points in the right direction. S is sort of a special case because S could connect to any 4. Once we get here, we have to look if there's a mutual connection. So this pipe is connected to here, and this pipe is also connected back to here. S is special because it only needs to be like a one-way connection to S. But anything else, like, is there an example in here? J is north and west. Okay, so like these two are connected to each other. They're not part of the main loop. Right, J is north and west, is that right? J connects north and west. North, and for the camera west, but for me, this is west actually. J connects north and west. Yeah, so in this case, this J could connect up to here, but this J does not connect down here. So we have like a one-way connection, but a one-way connection is not, it does not count. It has to be a two-way connection for everything except S. Right, because when they gave us this first puzzle prompt, first they showed us an F here, because that's the actual two-way connection to this neighbor and that neighbor, but then they said, well, we're just gonna like put the animal on top of the F as an S, and you just have to infer that there's an S under there because it has to be connected to things. My cat is playing with some cardboard boxes in the background, so if you hear some scratching noises, that's what that is. So we're going to start at S, and we're going to have some special rules for S, but then once we get off of S, it has to be mutual connections. And before that, we have to make a quick scan to find S. I think I want to do it at the same time as loading the grid. So we get the grid size. We load the grid and find the position of S. And S is the start. According to the story of the puzzle, there's some kind of animal there, but you can just ignore the story if you want to focus on the abstract nature of the puzzle. Just thinking about like what I want to name my variables and how I want the rest of this to work, but for now I just need to mark the position of S. So if grid ix iy equals S, I'm going to call these ix naught and iy naught. This is like the initial position. And those better be found. We don't have to worry about some pathological case where there is no S. We're just going to assume that we find these. And there's not going to be any error handling in the case that we don't find those. I have to declare those variables. Those are not the names of the variables. There we go. Okay, so it's at 1, 1. I don't have any separator in there, so it looks like 11. There we go, 1, 1. And that's exactly where the S is. It's 1 from the left, and then the Y coordinate is positive downwards. That's the convention that I'm using because that's the order that I read the file in. So S is also 1 from the top. Now we're going to have some kind of loop that goes around the pipe. And I want to make sure I want to loop until I get back to S. How do I want to do this? Let me glance. I never saved the real input. I also want to look at that. This is like 140 by 140. And where is the S? It's somewhere in the middle. As long as it's somewhere in the middle. So do I want to loop until my current position is S or until my previous position is S? maybe we need to keep track of 3 positions. Maybe the current position, the previous position, and the next position. I don't know if we need 3 variables though. I think we can swap these around efficiently, because you don't want to get stuck in a loop. Like you don't want to go from S to here and then somehow go from here back to S. You want to make sure you keep traveling in the same direction that you started. So if you go from S to here, the next position that you go to has to be here. You can't go back to S immediately. Actually, I want these to be named differently. So there we go. Took me a while to get into that Vim rhythm. But it didn't seem like they were enough that I should have recorded a macro to replace those, or done like a global, %s search and replace. So this will be the start position, and we're gonna save this forever. These are, once we get through this loop, IXS and IYS are basically immutable. We're not going to change these. Then we're also going to have the previous and the current positions. And we're going to start at the start. So initially the previous position will be the start, and then we're going to search the 4 neighbors to find the next position. Still not what I want. So the current position is going to initially be S. No. I think I like it like this. And then we're going to initialize the current position to something, some dummy value, just to get into the main loop. And then we're going to loop while these things are not the starting position. Actually, this should be an OR. I think maybe it makes more sense to write it like this. Yeah. So, do you guys know about De Morgan's laws? You can distribute a not operator into parentheses. It's like the same way that you can, if you had an expression like 2 times 3 plus 4, you can distribute that 2 multiplication inside the parentheses. So that's 2 times 3 plus 2 times 4. You can also distribute Boolean operators. So you can distribute the not into here, And what it does, it changes every equals into a not equals, or vice versa, and it changes every and into an or vice versa. So this is the same thing as that. So I initially had it wrong. I initially had this, and then I changed it to or, and then I was like, well, actually, I think it makes more sense to write it like this. So that's what I ended up with. And that's called De Morgan's law. De Morgan's laws. There's more than one of them, I guess. Yeah. So I guess they have this as two different things, but I think of this as one thing. Do I have this open in two tabs? Why did I do that? Okay. So this is the loop. And maybe I just want to do the first step and then quit. Yeah, because I really have to have this whole loop implemented for it to actually get back to the starting position correctly. So if I don't implement everything on my first attempt, it's going to be an infinite loop. So I think I also want to have a way to break early. And k less than 1. So you don't really need this k, but I want to have some way of getting out of this early. So I can test one step and see if one step works before I implement the whole loop. Okay, so that is not an infinite loop, but without that, this is an infinite loop. So we have the current position and we have the previous position. And then at the end of this loop, we're going to want to update the previous positions. So we're going to want to look at the 4 neighbors of S, or the 4 neighbors of the current, the 4 neighbors of the previous position, and see if they're connected. So these are just going to be several cases. How do I want to handle this in a consistent way? We're going to need an other loop inside of this loop that loops through the 4 neighbors. And we're going to search for a neighbor that connects in both directions. Or if it's S, it only needs to connect in one direction. I think connects. Maybe that makes more sense than connect. So we're going to have 4 cardinal directions, and this loop is going to loop through the 4 cardinal directions. And those directions, cardinal directions, this is going to be a table. And basically we're going to have the positive x direction. We're going to have the negative x direction. Let me get this lined up. We're going to have the positive y direction and the negative y direction. Yep. And then this is a table, so I also have to specify the size of the table. And this is 2 by 4, or is it 4 by 2? I think it's 2 by 4. Yep, so positive x, negative x. This is like x comma y for the first direction, x comma y for the second direction. So we have east, west, south, because y is positive downwards, and north. There's OBS. And north. Now, this inner loop has to go through the 4 cardinal directions until it finds a neighbor in that direction that connects to the current point, or the previous point, whatever. IDIR is going to index into the directions array. So now ix is going to be a neighbor of ix naught, so it's going to be ix naught plus some direction. So it's going to be ix naught plus dirs. Now the first index of the dirs table is x or y, so because we're incrementing an x value, this is going to be 0, and then IDIRs, or IDIR. And then we're going to increment y in a similar way, but this is dirs 1 now. So I want to know the previous position, and I want to look at the directions or the neighbor positions that I'm searching. Well, that's an infinite loop. 2 by 4. Yeah, now this is an infinite loop. So I should have gotten the first 4 correct, I think. So we start at 1, 1. There it is again. And then the neighbors of 1, 1 are 2, 1, 0, 1, 1, 2, and 1, 0. And then I start like indexing out of bounds and I get garbage values. But that's okay because I haven't implemented the rest of this while loop. I need to figure out if they connect or not. don't know how to do this cleanly. I might just have a block of like 8 to 16 if-else statements. Because we're going to have permutations of the current character and the next character, and then which direction they are relative to each other. And how many combinations do we have? Basically, I have 8 different characters and 4 different directions. But maybe we can simplify these and think about it instead of the current and the next character. Maybe we can think about these as pairs of up-down pairs or a left-right pair. And then we can swap them if we need to, and we don't have to worry about which one is current and which one is next. I'm still going to have a lot of cases, but that can reduce my cases by maybe half. East, west, south, and north. So if we check east first for this particular test input, if we start at S and go east, they should connect, and the first thing that we check should be a connection, and then we're not going to iterate through anything else. We're also going to have to make a second pass through this loop. So we're going to have we're going to worry about this later, but we're going to have to keep track of where we go from S, and then the second time we traverse this pipe, we're going to have to make sure that we don't go east the first time. And then we'll check east, west, and then I think south is next. I forget whether south or north is next, but then we're going to check south, and then we're going to traverse the pipe in that direction instead. But the first pass through, we're going to go from S to the east. So I think I want to conceptualize this in terms of left-right pairs and up-down pairs. And then I don't have to worry about previous and current. It's easier to think of them in their spatial relation to each other rather than start and current or previous and current. So the only way I can think of handling that is having another if statement, where if either is, so if it's east or west, it's going to be a left-right pair. If it's south or north, it's going to be an up-down pair. So if it's 0 or 1, it's a left-right pair. Otherwise, it's going to be an up-down pair. We're using north, south, east, and west cardinal directions, so let's be consistent with that. East-west pair, and then north-south pair. Where did those letters come from? Okay. These are characters. So we have character east is current, and then character west is next. And then if I have that wrong, we're going to swap them. So IX, IY. Let's get a little space in here. Okay. So that sort of assumes that we're going west, because if current is east and next is west, we have to be going to the west. So that means this direction. But if it's actually dir 0, then we have to swap those two. There's probably a way that you could do this with a lot less code. But this is the choice that I've made for myself. Okay. So at the end of this, CE should be the one on the east, and CW should be the one on the west. I want to print these in the other order. I want to print from left to right, so I want to print west and then east. And these are just going to be concatenated together with no delimiter, and I want it to be like that in this case. So we should get two new things printed here, and then a bunch of junk like before, because we still have an infinite loop to take care of. But one thing at a time. Okay. Is that right? Yeah. So if we traverse to the right, we have S dash, and then if we traverse to the left, we have 7S, and these characters are in the correct order. One of these is swapped, and the other is just in the initial order without going into that if condition. And this whole else clause is just a to-do. I guess we're going to try to get east and west first. Yeah. No. I might change my mind and approach this some totally different way. But let's see how this shakes out. North, south. So if it's north-south, we assume that we're going to the south. But if I'm going to the north, then I want to swap. So which direction is north? North is 3. And I think it's time to parameterize these things. So, now instead of having like magic numbers 0 through 3, which refer to positions in this table, I have readable names. So I want to replace those. This I still want to initialize to 0 because it's going into a loop. And yeah, that gets incremented. That's good. So if this is east or west, now if we're going from east to west, so if the direction is west, I want to swap. And this is going from north to south. So if the direction is actually north, yeah, if the direction is north, I want to swap. I want to print these on 2 different lines so it looks like it's north and south. So is the last thing that we checked still correct? So we should have a 7s and an s dash. And no, we got it backwards when we parameterized those things. What about the other direction? We should have an ls and then s pipe. Yeah, we have everything backwards. Why? What did I have here? I had 0 there. So 0. Okay, yeah, that should have been east. And then I guess this one was wrong too. Okay, so we have S dash and 7S, that's good. Then we should have LS and S pipe. No, I had the north-south part right before, yeah. LS and S pipe, okay, yeah. I don't know why I thought that was wrong before. LS and S pipe. LS and S pipe. I think I was just looking for this thing to be up here, and like I saw them in the other order and I thought it was wrong, but this pair is correct and this pair is correct. So now we're gonna have a bunch of cases. I mean, you could like fill out a Boolean table, I guess, and look it up like that. But I don't see a huge difference one way or another. I think I'm just going to do it with a bunch of if statements. So what are our options? I think I have to look at this in an other monitor. So first of all, if either of the characters are ground, meaning the dot, if either of the characters is a ground, then there's no pipe and there can't possibly be a connection. Now, if one of the characters is S, that can connect in any direction. So that's sort of like a bi-directional thing. But the ground is the easy one to rule out for now. I mean, connects is already false, so we don't really have to set it to false, but yeah, this does nothing because connects is already false. So what we want to look for is the pairs that do connect and not worry about the pairs that don't connect. So what combinations could we have? So if we have west, how about this? CW plus CE equals, this concatenates the strings, so this is a little bit easier to think about. If we have horizontal pipe and then another horizontal pipe, that's a connection. So connects is true. But instead of doing it like this, we could say connects or equals. Is it any less verbose if we have an or equals? Because I don't really have an or equals operator. Okay, so that parsed. I just wanted to make sure that the syntran interpreter could parse my code without having any syntax errors here. So that parses. What possible east-west connections could we have? This is going to be error prone. I'm probably going to miss some. There are three. If we assume that like we have one of the characters as a horizontal pipe, then there are three valid connections to that to the right. You could either have a 7 which connects down, or another horizontal pipe which connects to the right, or whichever pipe connects north. I think that's J. J connects north and west. Yeah. So where did I put that? Okay, I deleted that somehow. So we have three options here, assuming that the left character is a dash. So we could have a 7. This one is straight out of the example. You can have a dash 7. That's a valid connection. Or you could have a dash dash, or you could have a dash J. This is also in the example. So in this sample, we have a dash J. That's a valid connection. Now, what are the valid connections if the first character is a vertical pipe? So a vertical pipe, there aren't any. There are no valid vertical pipe connections east-west, because this whole block is an east-west pair. So if we have a vertical pipe, that cannot be a connection. Let me just like list out all of my characters so that I can think about all of the permutations that I have to check. We have pipe, dash L, J, 7, F, dot, and S. So there's actually one more here. We could have a dash S, because S can connect to something in any direction. Two, three, four, five, six, seven, 8. 1, 2, 3, 4, 5, 6, 7, 8 different possible characters. So these are all the valid combinations starting with a dash. We don't have any starting with a pipe. Now, can we have an east-west connection starting with an L? Yes, there are 3. Or there are 4. Because S is like a wild card. S can connect in any direction. So we've ruled out this case, we've covered this case, and now we're looking at the L's as the first character. That's not what I wanted to do. Replace L. So an L can connect to a dash. It could connect to a J. Dash, J, and 7, right? And then the wild card. Do we have an L7 anywhere in these examples? So like here's an L7 in the second test input that they show us. So L7 is valid. Okay, now what can we have starting with J? If J is on the left, there's no connection to the east. So we don't have to worry about that. 7 can't connect to anything to the east. F can. I believe F can. Oh, notice. Yeah, we might be able to refactor this after we spell it out, but we have 7-JS, 7-JS. I just wrote them in a different order, but they're actually exactly the same. The only difference is that the first character is different. Yeah. So F can connect to the east, right? Maybe instead of adding these all the time, I could optimize it by just, adding them once and then not having it inside every condition. Yeah, I think I want to do that. So this is character east-west, just concatenated together. But it's really CWE because I want them in that order. I can do some fancy block editing since I have everything perfectly aligned. Okay, so F's can connect to the east, dot cannot connect to anything, and then S can actually connect to everything. Or everything except ground. S can connect to everything except ground. We're never going to have an SS, but I'm going to leave it in here for symmetry. So S can connect to almost anything to the east. So for example, we cannot have an S vertical pipe because there still has to be a one-way connection. Like the vertical pipe does not connect to anything to the left or the right. So that's not valid. We still have only these 4 cases. But I think that's it for the east-west connections. I think those are all the permutations. Right, we have no vertical pipes. We got these 4 cases. We got these 4 cases. There are no J's. There are no 7s. We got these 4 cases for F. There are no cases for dot. And then these are the 4 cases for S. So I think that's it for the vertical connections. And my loop should actually make it 2 steps now. So I said that we should start from S and go to the east because we're checking the east direction first. Yeah, actually we should get that, and then we should get from S to 7. And then we're stuck because I haven't implemented the north-south search yet. So I think maybe I want to break at k equals 2, but I want to see if I can get the first step first. Wrong types. Variable undeclared. Is it CWE? Oh, CW plus CE. That's what I wanted to do. So we have S dash. Apparently we find something. And then we break immediately. So I want to break. No, I want to break at k equals 2. So we have an S dash, and then we should have a dash 7. Yep. And then we'll get stuck if I try to do one more step. It should kind of go into an infinite loop here. I don't know how that didn't just crash. Anyway, we have to implement the north-south check. And this is a little bit more painful because my code is not going to look as nice. So in these conditions, these two characters are actually laid out to the left and the right of each other. For north-south, I can't format the pair of characters in a nice way, so it's going to be a little bit harder to think about. CWE. Now we're going to want a CNS. Instead of CWE, which is two characters concatenated together, I want CWS. Okay, so what is a valid north-south connection? So it could be pipe. Remember, these characters are not actually laid out like this, so we have the north character and the south character, but I'm just concatenating them into one string for convenience. So these are harder to think about, but pipe can connect. And we should have 4 characters that are valid that all start with a pipe. So pipe could also connect to an L below, that's in the test input. Pipe could connect to a J below, that's in the test input, which I'm looking at in my other monitor. And then it could connect to S, which is like a wildcard. So that is valid. Dash is never going to connect to anything below, neither is an L. Neither J is northwest, yeah, J is not going to work. 7 will work, so we're going to have these 4 again, but then with a 7 instead of a pipe as the first character. So those should all be valid. And then F, we're going to copy and paste. That's not what I wanted. I use a Dvorak keyboard, so Y and F are right next to each other. And then S is the wildcard. I think that's it. That should get us all the way around the loop, I think, unless I have other bugs. It's very likely that I have other bugs. So basically we have 16 valid connections here, and we have another 16 here for the east-west pairs. You could probably write this in a lot fewer lines of code, like maybe have a Boolean matrix that encodes all of these valid connections. But I don't know if that would really save you much code. Right, it's not CWE, it's actually CNS. Crosby, Nash, and Stills. I think we got stuck at -7. No, we just broke out of the loop. So S-7. And then we should update. So we should go to the next position. So why did we get stuck at the second position? Oh, I know. We got into a loop. So we went from S to dash, dash to 7, 7 to pipe. And then I think we went from pipe back to 7. So I have to make sure I don't backtrack. So I think I can handle that somewhat elegantly without too much copy paste. So is that what happened? From S to dash, dash to 7. So we always check east first. So we go from S to the east, and then we check east first, and that's another valid connection. So we go from dash to 7, east, west, north, then we go south, so 7 pipe. 7 pipe should be... Oh, but this is an east-west check. What am I printing? I think CNS. CNS is not getting printed anywhere. Yeah, I get stuck on -7. So I go from S to the dash, then I go from the dash to the 7, then I go from the 7 back to the dash. Back at it again. I'm getting stuck, not in a loop because I want to get stuck in a loop, but I'm not going around the loop in one direction. I'm starting to backtrack. Part 1. I think I need to keep track of 3 positions. I need the current position, the previous position, and the next position. Or like current, previous, and before previous. And that should keep me going in the same direction around the pipe. So IX is the current position, IX naught is the previous position, and IX naught naught is before the previous position. It's like 2 steps back. And then whenever I update the previous position, before that, I want to update the before previous position. I've already been criticized for my terrible variable names, so I know these variable names are too short, but that's my style. And then if I'm stuck in a loop, I don't want to count that as a connection. Where do I want to put that condition without having like another nested level of indentation? I think I just want to do it down here. Okay, yeah, so that got me out of my backtracking. So we start with S dash. I need to open this up somewhere else. So we start with S dash, we go to the right, then we should have a dash 7, and then 7 pipe, so 7 pipe, and then finally pipe J. And then I'm just stopping after 4 steps because that was enough to figure out. Maybe we can go all the way around the pipe now and take out this early break. So we finally ended up at pipe S, and we're back at the start. So that should be like 8 steps. Yeah, I think that should be 8 steps. So we traverse the pipe in one direction, and then we're going to make a second pass where we go back around in the other direction. And then we'll know all the distances. So K is already counting, so I don't need a new variable for that. And then I want to keep track of the distance from the start for each point. So where do I allocate grid? Wherever I allocate grid, you can do it in one pass. I don't know if I'm clever enough for that. Yeah, maybe I'll think about it later today. I assume for for part 2, there's probably going to be something where like I have to do it for one pass, and I just won't figure it out if I can't. So wherever I allocate the grid, I want to also keep track of my distances. And yeah, I can initialize it to 0. And then as I'm going through the loop, the distance of the current point will just be the loop counter. And then I should be able to print that. Well, okay, I'm off by 1. So we have 0, 1, 2, 3, 4, 5, 6, 7. How? Yeah, it should be previous. Because we've already gone to the next step. Did I save that? Okay, yeah, I've already updated, so I have to do it up here. Okay, there we go, 0, 1, 2, and basically we're right up to 4, and then this part is wrong, but the way I'm going to do it, I'm just going to make a second pass in the other direction. If you know the length of the pipe, oh, yeah. So it can't be more than half the length of the pipe, or half plus 1. What if the pipe has like an odd length? Is that even possible? It's probably not possible. I guess it might always be even. That's a very nice hint, because I was planning to copy and paste that giant block of like 50 lines of code and do another pass with some weird logic to make sure I start out going in the opposite direction. Yeah, but that should work. Yeah, so the furthest point from the starting point just has to be the distance divided by 2. So I don't even need an array of distances. Yeah, I can probably get rid of this array, but I'm not ready to commit to that yet. So the max dist is 8, and then yeah, the answer is just half of that. Yeah, I'm trying to think of like some kind of path where it's not even. Like if you had a path where they weren't all cardinal directions, maybe, but this is like a regular integer grid. So wherever you go east, you have to go west at some point to make up for that. And wherever you go south, you have to go north again to make up for that. So I think it always has to be even. You know, if we were doing with floats, then all bets are off. But because we're doing with integers, I think it has to be even. Divided by 2. So part 1 is 4. So we do have 2 different test inputs. I don't know if I'm going to bother checking the other test input. Let's just cut to the chase and see if that's right. I probably have to get rid of all the debug printing. Part 1 took 90 seconds. This is probably going to take at least 90 seconds if it prints all this junk. Huh. Well, this could be wrong. All right. I know Bash is also an interpreted language, but I'm surprised that that took, what, like 18 times, maybe 15 times faster than bash. This is also inefficient. And like the language itself is just inefficient to begin with. So the only thing I have going for me is that I don't have to deal with any memory leaks today. I have a really bad memory leak that has killed me for like the past 3 or 4 days in a row. But today I don't suffer from that because I'm doing everything in one function and I'm not calling any other functions, which would aggravate my memory leak. Okay, that's part 1. Let's read part 2. Oh, now I need to depth first search or flood fill somehow. Wait, what? Okay, so the I's are included and the O's are not. What are the O's? Are not in the loop. Yeah. Oh, so this is tricky. Yeah, this might wreck me. If I need a recursive algorithm, I cannot do this in my language. Like I think I could do a flood fill iteratively, but this weird case, I have to think about this. Oh no, these are still outside the loop. Okay, yeah. Hopefully I can do it without recursion. Can you have recursive functions in Bash? Well, if you, I guess you must. Yeah. Cheating. Wait, I've this is like font rendering. I've done a font rendering project. It's not this one. I just need the URL. I've done a font rendering project, and what you start out with is the outline of every glyph or every letter. And then after you have the outline, you have to sort of flood fill the inside of the letter. And I did this with raster graphics. Yeah. Omega lol? I don't know what omega lol is. Oh, for your solution. Yeah. But my font filling algorithm was really tricky to figure out. You scripted image magic. Oh, yeah, that. Well, I don't know. You have like self-imposed rules for yourself. Like I saw the last day or two where you said you didn't want to use awk because then you're not using bash, you're using awk. But I don't know. It's kind of valid. Yeah, I need to refill my coffee, so I'm gonna take a short break, and then maybe I'll attempt part 2. Be right back. Okay, we're back. So the reason that my font filling algorithm was tricky is because I wanted to do it efficiently. I wanted to make one pass through all the pixels and fill everything without checking any pixel more than once. But if I take like a more primitive flood filling attempt or flood filling method, I can find a pixel that's inside and then flood fill from there. And then every time I find another pixel, I'm going to flood fill again. So it's going to be inefficient because I might be flood filling some pixels more than once that are already filled, but it might be easier than like the complicated font rendering algorithm that I've done. Yeah, there are a lot of ways to do this. I think there were a lot of ways to solve, was it day 9? Yeah, so the way that they hint at you to do it is to like, I conceptualize this in terms of derivatives and integrals. So like you're getting differences going down and then you're doing sums to go back up. So those are like discrete versions of derivatives and integrals. And my friend was like, you have to know calculus to solve day 9? I was like, well, not really, but that's just how I conceptualized it. But like what you're really doing is extrapolating a polynomial. And if all you want to do is extrapolate a polynomial, you don't have to take the derivatives and integrals to do that. You could assume that they're coefficients like ax squared plus bx plus c, and then solve for those coefficients somehow, like maybe by inverting a matrix. So you could do that without like taking these derivatives. So there are definitely multiple ways to solve day 9, and I agree. I think there are probably a lot of ways to solve part 2 of day 10 here. Honestly, the tricky part is just finding one pixel that's inside, because if we can find one pixel, we can flood fill from there. But how do I find the first one? A concave hull problem. Yeah. So I had some really messy code just for part 1. Yeah, I'm okay with the flood fill part, but finding the first pixel to flood fill from, that's where I'm stuck. So I have like a lot of messy code where I have like 16 different cases that are a valid connection. and these are 16 cases for 2 characters at a time. Like these 2 characters are a valid connection. I think to find 1 pixel, I have to look at 3 characters at a time. And then my cases are going to explode from 16 to like 64 or 128. Yeah, and there's no way I can do that. There's no way I can do that without having at least a few typos, which would take forever to methodically find and fix. I don't know. I might just give up on part 2 today. I know I'm not going to get all 50 stars, so I have to start losing at some point. Yeah, let's hear it. It's probably something that I can't implement either. At least not in a day. Parody. I think, yeah, I'm not sure what you mean by parody, but it might be more like the font filling algorithm that I used. Yeah. The problem is if you're making vertical scans, yeah, yeah. So like if we scan through this row, that's easy, right? Because you're outside, you hit this, you go inside, then you hit the other one, and you're back outside, and that's simple enough. The tricky ones are when you hit these literal corner cases. So you hit the S. Are you inside or outside? Well, it kind of depends on the whole loop. Yeah, if that might be the way to go. And I might cheat by like copying and pasting my font filling algorithm. But I'll have to translate Fortran to syntran, which is ironic because syntran is implemented in Fortran. Where do I fill? Yeah, it's winding numbers, parity, whatever you want to call it. Draw glyph. So this is my draw glyph function. And then I have an array of winding numbers. There's a loop through contours because glyphs can have multiple contours. We don't have to deal with that for the pipe problem. Like the letter A or letter alpha, it has an outer contour and it has a hole in the middle. We don't have to deal with that. We might have, why do I have day 9 open still? We might have stuff like this where it looks like there's a hole in the middle, but we still have one contour. Like there's just one pipe that encloses this whole thing. So I don't need the contour loop. X out of this. There we go. Okay, so font glyphs, they can have line segments or they can have Bezier splines. Fortunately, we don't have to deal with Bezier splines yet for Advent of Code. There's no way I can translate this from Fortran into syntran. Fortran uses one-based indexing for arrays. And if I have to translate from one-based to zero-based, I'm going to make a mistake somewhere. I think I have to at least attempt this, and I might not finish it on the stream. I have to eat lunch at some point. But I think I might start this. I might regret it. Maybe I should just give up now. Or shell out to image magic. Yesterday, no, not yesterday, 2 days ago, on, was it day 8? Yeah, on this problem, we sort of had to deal with big numbers in part 2 and get like the least common multiple. For that, I initially shelled out to Python because I didn't want to deal with like big numbers and least common multiples. So I have shelled out before, but I actually don't know how to use image magic like that, so I'd rather just implement it myself. And if I can't figure it out, that's okay. It was harder to figure out how to make image magic do what you want. I've used magic to like convert PNG to JPEG or vice versa, and that's about the extent of my experience. Zero out of 10. Come on, how do I copy? Fine. I'll open it in Firefox and then copy and paste into Chrome. Wow, those are a lot of arguments. It doesn't look that bad. It's nicely formatted. Oh, you have to use anti-aliasing. Or does plus anti-alias turn off anti-aliasing? Okay. Yeah, I don't know how many hours you put into figuring out that command, but just seeing the final result of it, it looks okay. More than one. Yeah. If I have to put more than 1 hour into this, I don't know if I have it in me. Okay, I'm going to look at this in another monitor and then start translating into syntran. We have like transforms that I don't have to deal with, and we have floating point stuff in here that I don't have to deal with. Fortunately, we only have integers in Advent of Code. And I want to copy and paste part 1 to part 2 before I really start this. That should be less verbose. Okay, yeah, now it runs in less than a second. Not bad. But part 2 might get nasty. And this will just run part 1 twice. Okay, so all of this from part 1, we're going to keep that. I can get rid of a little bit of junk. No. That's not debug only. I actually need that line of code. So all of the distances that are 0, they're either outside of the pipe or inside the contour of the pipe. But anything that is non-zero is on the contour, if we use like font terminology. Do I need multiple passes? I don't know. So I have to keep track of whether I'm on the first point or not. Sorry, I try not to do this on stream, of having like something on another monitor that I'm looking at, but I don't think I can get around it today. So I'm looking at my font filling algorithm on the other monitor. This will keep track if we're on the first point or not. So this is an array of winding numbers. It's going to be 0 on anything that's off the contour. And then I think it's +1 or -1 for anything on the contour, depending on whether you're going in or out when you scan from left to right. And then this is some sort of scalar that's keeping track of like the winding increment for the current pixel. I honestly can't even remember what my code does. I'm just mechanically copying and pasting it because I wrote this like 8 months ago and I don't remember what it does. And defer has like some special logic for when you get back to the first point. I can do all of this after I load the grid. So at the end of this loop, we have basically the current pixel and the previous pixel. And I have to make sure I do this before I start updating those things. And like after we do this loop, there's going to be another pass that like looks at the parity and fills everything inside. But this just has to take care of things on the contour and keep track of whether you're going into or out of the pipe whenever you cross the pipe. And that's what the winding array keeps track of. So we have the current pixel and the previous pixel coordinates. And then I want to look at their y values. So I want to look if the y value is going up or down, and if it's going left or right, it's 0 and I don't care. So wind ink. What is wind ink? Where did I initialize that to something? Sorry, other monitor. Okay, no, it's just set right here. This is the sign of the difference in y values. So it's gonna be iy minus iy naught. And I need a helper function here, so I have to implement that. And my convention is that sign can return 3 values. It can return -1 or 0 or +1. So I get to implement that. I think that's it. Let me unit test that real quick. I'm not ready for this yet. Why is that returning a Boolean? Fine. Okay, sign of 0 is 0. Those look sane, and then if I do 2, it should keep the sign but give me a magnitude of 1. Alright, that seems to work. Now, where was I? Other monitor. So the increment of the winding number, this is not really the winding number itself, this is like a relative change in the winding number, I guess from like the previous pixel to the current pixel. It's just the sign of the difference of the y values. And yeah, maybe I didn't really need a sign function because this is never going to be greater than 1 or less than -1. But maybe I do need it. Now, I have a whole bunch of logic that I have to translate from Fortran into syntran. By the way, here's one of the things I hate about Fortran. So this is like the normal not equals operator. In Fortran, this is the not equals operator. because Fortran doesn't have compound assignment, so like in a normal language, this would be compound division assignment. It's one of the things I hate about Fortran. Wind inc 0, so we have to keep track of the current winding increment and the previous winding increment, because there's like a lot of complex logic. If you're going around an elbow, what happens to the winding number? Or if you go down an elbow or up an elbow, it's mind-boggling to think about. But fortunately, I've already solved this somewhere else, and I should be able to just mechanically translate the code into another language. Okay, what the hell is this? Okay, the deferred pixel. Yeah, because defer controls special logic for the start point. Because the start point, it depends how you go out of the start point and how you get back to the start point from which direction. So we have to keep track of that deferred pixel. And like all of this stuff is undeclared, so is winding not, so I have to go back and declare those at some point. Let me like put in a reference for this. This might not be that bad. I'm looking at about 20 lines of Fortran. So it might not be too bad to translate this. Famous last words. Maybe I'll spend all day struggling on this and never figure it out. Hold on, I want to permalink this to like a specific commit just in case I go back and change that. Don't know how to use Google Chrome. What is the commit? There we go. Browse files. So the logic basically starts here. And I'm going to have to mechanically translate up to about there. So yeah, that's 20 lines. And now I have a permalink referencing a specific commit. So in case I change this later, it will still be valid. I have compound assignment in this language, so I can simplify this actually. Because Fortran does not have compound assignment at all. So this is way more verbose if you have to do this in Fortran. Because you have to have this whole expression on the left side and the right side of your assignment operator. And then finally, again, I can use compound assignment. And what happens to first? First is true. Then we have this. Getting close. I also have to declare this somewhere, I think. And I have to do something for the deferred point. I would probably not figure this out if I did not have code that does this. Now, outside of the main loop, we have to deal with the deferred point. So out here, winding D, I think that's another thing that I have to set somewhere. Did I set winding D? I think I might have to set it in there. Wind IX D, that's a variable. IYD plus equals winding D. So I think this is redundant, but this is how my Fortran code works. So what is winding D? Yeah, I forgot to set that. So defer equals true, X and Y, and then winding D equals winding. That might be most of it. I think I have to declare these things. This is a one-liner, so I don't need brackets or braces. Okay, so I think that will give us the winding numbers on the contour. Then we're going to have to make a pass through each pixel and then fill things in. And that's going to be like a separate loop. But I want to see if this winding stuff is correct. I think there's other stuff that I forgot to declare. IXD. I forgot to declare IXD. And these better get initialized at some point. All right, let's see if this parses, and then let's see if it runs. It probably won't parse. Yeah, I forgot to declare winding D. Do I ever initialize that in Fortran? No. Well, that did something. Let's look at those winding numbers. I should really be running this on the test input. So we're going to do that. Let's do the test input. This will fit in my console, I hope. Okay, actually that's it. So it depends on what your sign convention is. Either -1 is going in or -1 is going out. For our case, we just care if the winding number is non-zero. And these are like the winding increments. They're not the winding numbers yet. So we're going to scan everything from left to right. And so the first row, it's all zeros, so nothing happens. On this row, we're going to scan. We start at 0, so we start outside. When we hit a -1, we're crossing in. So now if anything after that is non-zero, we're going to fill it. Also, I'm going to have a problem. I think I have a problem with the contour itself. Yeah. This is... Okay, we can easily fix that with a second pass. So we know where the contour is, so we can mark everything that's on or inside the contour. So that's going to be these 3 values in this row, these 3 in this row, and these 3 in this row. And then we're going to have to subtract the actual contour from that to find out just this one thing is inside. So we're going to have to do like a few passes to figure that out. But I think this is it. And I guarantee you, I never would have figured this out within 1 day if I hadn't already done this, because making sure that you get this number correctly at the start point, it's a pain in the ass. Because like it depends the direction that you go into and the direction that you go out of the starting point. Trailing white space somewhere. And what is the puzzle actually asking us for? They want only things that are inside, right? Like they don't want us to count the contour. Or they want I's, not O's. O's are outside, I's are inside. So I'm just working with the original test input. So in this original test input, there's 1 point that's inside. There are 9 points that are on or inside the contour. But if you only count the ones that are inside and not on the contour, that's 1. So we're going to make one pass and we're going to get all of these that are 9. And then we're going to subtract the contour itself. And we already have that from part 1. Part 1 is like k, or the max distance. That's the number of points that are on the contour. So we're going to get everything that's on or in and then subtract that other number from it to get the right answer. And that is done, actually. So I was copying and pasting this kind of stuff for the code that I just wrote in syntran. And then after we get the contour winding increments, we make this pass at the end. So now I have to copy and paste that part. Or not copy and paste, but mechanically translate from Fortran into syntran. Do. I was about to write a do loop, but this is syntran, not Fortran. We're going to scan one row of pixels at a time. So when we're scanning one row, we want to keep track of whether we're in or out, and we initialize that with wind num. So that gets initialized inside this loop because we're handling one row of pixels at a time. Wind num is actually plus equals the thing from the array that we just set up for the last 20 minutes. So it's going to be wind ix, iy. And so we're not really marking, we're just we're counting. Now, if wind num is not 0, increment the count. So for this input, we should get 9. We should get 3 plus 3 plus 3. That's a total of... No, this isn't going to handle that case correctly. I think we can have a little extra logic. Or I think that should get it correctly. This is not the final answer yet. This is the number of points that are in or on the contour. Then we're going to have to subtract the other thing. Okay, so that's 9. And then the sum, the final answer, is n minus k. So k is the max dist, and I think we haven't touched k. I want to have another name for that variable, actually. Because the max dist is the number of points that are on the contour. So if we subtract the points that are on the contour from the number of points that are in or on the contour, we end up with the number of points that are strictly inside of the contour. And that's the final answer. And it should be 1. It should be just this point for this input. Okay, let's try that on the real input. That's not right. How did I get a negative number? Is it integer overflow? No, because n is not overflowing. What was the max dist? Let me just print this again lower down. So that doesn't make sense. I shouldn't have to do this, but I'm going to have like another 2 more Boolean arrays. I'm going to have a Boolean array for on or in, and a Boolean array for on, and then I'm going to do like a Boolean operation to subtract those and count that instead of just subtracting these integers, because something funny is happening here. And let me go back to the test input. So at this point, we basically have a point that's on the contour. So on, but it's also on or in. Now we also want to do this in the other loop. I don't think this is right. So what I had in Fortran was just that much. And now I want to do one final pass that figures out if things are in but not on. If in and not on, then increment this. And I should hopefully get a positive number here, and for the test input, it should also be 1. So that's not right. Initialized this. Y, Y, X, X. What? I wanted to do that. So of course it was 0. There we go. So only this point is in but not on. So that's 1. And the real input should at least be non-negative now. 273. It's a shockingly small number. Oh, wow. That was a tricky one. I got lucky because I've solved that problem before. If I hadn't, it would have either taken me a very long time to do this, or I most likely would have just given up. So that was fun. And I'm about like at the limit for how long I want to stream. I've been going for 2.5 hours. I need a break. But I'm going to commit this and push it. How's my leaderboard doing? I feel like today was tricky. Okay, there are a couple people who haven't figured out part 2 yet, but I did, so I'm feeling good. Jacob Williams is the GOAT. He wrote JSON Fortran. He wrote a JSON parser in Fortran, which I use everywhere. It's a fantastic library. All of these people are cool. They're all active posters on the Fortran forum. Yeah, so let's get that committed and then end the stream. I never used test input 2. Yeah, I never had to resort to using the second test input. So we added the sign function to utils. And then we have, did I not add? Okay, I added dot. So these files are added, right? Yeah, the logic with the deferred point is really tricky. So like I can't properly explain it because I honestly don't remember how it works. I wrote this like 8 months ago or something, but I remember it being very difficult to figure out. I also have a stream on that. So can I do a YouTube? Am I logged in here? I don't know if I'm logged in. Yeah, I'm not logged in, so ignore these recommendations. I don't know what the hell this stuff is. Is this me? Why do I have random numbers after my name? I look like a bot. Where's my Kali playlist? Okay, so I have a whole playlist on this font renderer. And it was like the next to last episode. So the next to last episode, I worked on this exact problem, which I started out with the contours of glyphs, and then I had to figure out how to like fill these in. And it's the exact same problem that we did in Advent of Code. So here I'm like marking things as green or red. Green is going in and red is going out. But it's very tricky to get the literal corner cases, because up here on this top line, this is supposed to be a hyphen. So this is a hyphen and we should fill in the middle of the hyphen. It's very tricky because on the top line you have to go in, and then all of these points are still inside, but here you have to go out. But then what do you do on this lower corner? Here I have some kind of edge case where I hadn't quite figured out the logic just yet. So I was never going in, but here I was going out, and that was causing like some artifact to like shoot off to infinity with a filled pixel for this entire row along the bottom of the hyphen. And yeah, I guess that this might be the start point of the contour. And that's one of the tricky things. You have to get the corners correct because it depends whether you curve this way or if you curve and then you curve up at some point and come back down. And then the start point is also tricky because it depends on which direction you go out and which direction you go in, and like the neighboring corners next to the starting point. So did I figure this out on stream? What did I just do? It was a lot of work. This was another like almost 3-hour stream. I think at the end I probably got it figured out. Nope. No, I think I didn't figure it out in this stream. I had to take a break after 3 hours of streaming, and then I figured it out off stream at some point. So this is a tricky problem. If I hadn't done it before, I probably would have not figured out the Advent of Code today. I think I pushed this, right? Yep, day 10. Where's the actual code? What? Did I? Okay, I forgot to add that. Do that, and let's force push. Rewriting history, don't do this in production. Do not force push, never force push, except in throwaway Advent of Code. Yeah, so now I just messed up GitHub. If I go back here and look at the revised commit, okay, now we have 650 additions. That's more like it. And then here is the code that we just wrote. Part 1, not too bad. Still a little tricky just for part 1. That took like almost 2 hours of today's stream. And then part 2. Good. There's a very good chance I never would have figured this out within a day. Because you basically have a 24-hour limit to figure out an Advent of Code problem. And then if you start putting unsolved problems onto a backlog, you're never going to catch up by day 25. Hey, Kane. I'm just about to end the stream, so I just pushed this. And parts 1 and 2 are done for today. It's a Sunday, so I'm streaming in the morning. Tomorrow I have to work, so I'll probably stream around like 7 p.m. Eastern. You won't get a morning stream from me tomorrow. And I'm not going to stay up at midnight. If I tried to solve this at midnight, I would just never sleep. So like for my own mental health, I have to solve these during the day or during the evening. I can't do it at midnight. And I think there should have been a way to do this with just like n minus k, but I had to make these Boolean arrays, and that was enough work. I'm not gonna go back and try to optimize that. Yeah, so that's it for today. I'll catch you next time.